And are we recording? Yes. Good. So, question number 1. Here we go. Use an integer to represent each situation. So this one is pretty simple. Okay. So number 1, we're going to go gain of 20 points. A gain is something positive. Okay. Think about the situation here. Usually it corresponds. So something that's positive, something good. Gain of 20 points plus 20. Went backwards 4 spaces. Okay, we used the integer -4. Loss of 45, -45. Went up 9 floors, going up. Okay, a number line, vertical number line, so it's +9. Submarine is 200 feet below sea level. -200. Sea level 0, so all the way down there is -200. It's not that far down. Temperature rose 12 degrees, +12. Okay, that's one. That was easy. So number 1 was all about using integers to represent real life situations. Okay, very simple. Number 2, determine the quadrant where each point lies. Okay, so you got point A, -4, 9, -4, 9. So I draw a very crude, very small graph here. Okay, this is my X and this is my Y, and I'm just going to imagine myself traveling a little bit here from left to right and up and down. So A says -4, 9. -4, 9 means I go this way, -4, and then 9, which means I go up. So I am somewhere over here, and that would be Q2. So -4, 9 is Q2. B, 0 and 8. 0 and 8. So the first number is 0, so it means don't go left, don't go right. The second number is 8, so it tells me to go up 8. So I'm about there. That puts me not on Q1, not on Q2, but it puts me on the y-axis. C, -5 and -2. -5, go back -5 spaces, so I'm somewhere over here. And -2 tells me to go down to, so somewhere here in quadrant 3. D, 8, -3. 8, so I go 8 to the right, somewhere over here. And 3 down, -3, so somewhere over here. So that tells me that I'm in quadrant 4. Okay, so I can use one of these, okay, just to sort of figure out what quadrant I am going to land on. Okay, it doesn't have to be precise, just a guide. So E, 19 and 0. 19 and 0 means from the origin I go 19 to the right, somewhere over here. And 0, second number, don't go up, don't go down, means I'm standing on the x-axis. And then finally 0, 0. Well, 0, 0, I am at the origin, okay, the beginning. Okay, let's go move this down a little bit. 3, order the rational numbers from least to greatest. Okay, like I said in class, if it doesn't tell you to use a number line, you don't have to, but it comes in handy. So I am going to use one. Okay, and again, I'm going to draw a basic one. Let's see, positive numbers, negative numbers. Okay, 0, 1, 2, I might need 3, I think. -1, -2, -3. Okay, so let's do them in order. 2.25 is our first number, so that's something about here. 2.25. Second number, -7/8. Take your time, divide that up. 7/8. It should give you, oh, gee, do I actually, 7/8. Okay, I'm going to do the division here on the side, or better yet, 0.875. So that's very close to 1. -0.875. And I'm not going to use that number. I'm actually going to use, let me go back a little bit. So I am going to use -78, which is the same thing as 0.785. Okay, sorry, 0.875. Jeez. Next one, -0.75, and that's going to be here. Okay, then we have 2 3/8. Okay, 2 3/8. If you divide 3/8 and 3/8, actually I'll write it here, 3/8. So 2 3/8, the same thing as 2.375. Okay, so take this, divide 3 by 8, and you get 3.75, and that's going to be obviously a little bit bigger than 2.25, not too much. So let's write it over here. Okay, 2.375. Now we go to -175, so it's 0, -1, -1.5, -1.75 is about here. Okay, and then we have -1 4/5. Again, divide 4 by 5, and if you divide that, you get 0.8 or -1.80, 8 or 80, whichever one you want to use, doesn't matter. And that's a little bit smaller, so that's going to go just about there. -1, and 4/5. Okay, and that's it. Now that I have my number line, okay, let me just take a second here and erase this. And my numbers are plotted. I can easily determine the order just by looking at my number line and going from left to right. So smallest number, -1 4/5. Second one, -1.75. Then we have -7/8. Then we have -0.75. Then we have 2.25 over here, and 2.375 as our biggest number. Okay. So hint, use a number line. I think it would definitely help. Next one, explain how to go from -2, -4 to 3 and 5. Okay, so I will draw this. Okay, you can draw 1, 2, or use the graph that's on your test. So let's see, where am I? So we got 1, 2, 3, 1, 2, 3, 4, 5, and we have -1, -2, and -1, 2, 3, 4. Okay, so here you are, and it says that you're -2, so 2 back and 4 down, -4. It says that you're here, and you want to travel to 3 and 5. 3 and 5 would be 1, 2, 3, and 1, 2, 3, 4, 5 up. So how do you go from this point right here at the bottom, let's call that point A, all the way to point B? So talk about movement from left to right and up and down. Okay, so why don't we just simply count? So if I were to go from A to B, I would go 1, 2, 3, 4, 5 to the right. And how many up? You would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9 up. Okay, so to go from -2 to -4, again, talk in terms of movement left to right and up and down, you would go 5 right, 1, 2, 3, 4, 5, and then from here, you're going up to here, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, which would be where point A or point B is on the y-axis. Okay, so 5 right, 9 up. Move on. Sam spent 45% of the $80 he got for the allowance. How much does he have left to spend? So let's set this up. So we have 100. He spent 45%. 45 goes on top. 80 was a total amount that he had. So this is a part. This is a total. Remember that. No relationship here so far, so let's change it so that there is. Guess the most multiply top and bottom by 8. I got 800 over here. 8 times 5 is 40, goes 4, 32, 36. And that's the one I'm going to use. Okay, that's no longer in use. 800 to 80 is divided by 10. And 360 to go to our mystery number should also be divided by 10. So that is 36. 360 divided by 10 is 36. So this is how much. So 36 is how much was spent. Okay? And the question says, how much does he have left to spend? So you still have to go back here. 80 is the amount he had. 36 is how much he spent. Subtract 73. So final answer, 44 is what he, is it a he, has left. Could be a she. Well, anyways. Okay, and the computer's slowing down again. Oh, gee. All right, let's try to hurry up because I think the longer the video, the slower this gets. Okay, so next one. Jake has a collection of 120 comic books. 84 of the comic books are X-Men. What percent does that equal to? Very simple, very direct. Okay, so 100 now. So he has a total of 120 comic books, and 84 of them are X-Men. What percent does that correspond to? Nothing here, so what do? Let's multiply this by 10. That gives us 1200. Let's multiply the top by 10. That gives us 840. Good. Okay, we're no longer going to use that ratio there. Is there a relationship here? Yes, there is. Divide by 12. And here, we're also going to divide by 12. And that should give us 840 divided by 12 is 70. So 70% of his comic book collection are made up of X-Men magazines, X-Men heroes. That makes sense? Yeah, I'm just right. 70% are X-Men. The rest are other superheroes. Okay, now we're doing a little ratio. Ratio of cars to buses in the parking lot is always 5 to 6. There are currently 66 vehicles in the lot. How many are cars, how many are buses? Okay, so let's do this several ways. Let's do this using a tape diagram. Let's call that cars. Let's call that buses. A bad feeling about this one. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's for buses. Okay, and there's a total of how many? 66 in total. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes and 66, that has to go. How do I fit 66 in 11 boxes? So 66 divided by 11 gives me 6. So 6 is a magic number that goes inside all of them. Okay, remember, there's a total. It's not saying there's 66 buses or 66 cars, but there's a total of 66 combined. So that's true. 1, 2, 3, 4, 5. 6 times 5, there are 30 cars. And 1, 2, 3, 4, 5, 6, and there's 36 buses. If you add these two, 30 plus 36, does it equal 66? Yes, it does. So we're good here. If you set it up as a proportion, okay, what do I know? I know that there's 66 in total here. Okay, so this is a part to total proportion here that you're going to set up. So let's do cars. So I know that there are 5 cars in a group of 11. Okay, 5 cars, 5 buses. I'm sorry, 6 buses. Okay, that's the ratio. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So in a group of 11, 5 are cars, 11 are 5 are cars, 6 are buses. Okay, so part to total. Okay, so relationship times 6. This would also be times 6, and that also gives us 30. If I know the number of cars out of 66, obviously I can just subtract, and 66 minus 30 will give me 36 buses. So I have 30 cars, 36 buses. Either way you want to do it, that's fine. Okay, I think tape diagram is definitely easier in this case. Okay. Ta-dum. Find a better deal. This one actually it came a problem because two of them have the same answer, sort of very close. $3.99 over 16 ounces of candy. Then we have $2.99 over 12 ounces of candy. And then we have $5.99 for 20 ounces of candy. I want to find a better deal here. Divide top and bottom by 16 because you want to find the unit rate. Okay, and 3.99 divided by 16 equals, and I'm going to write a decimal here, okay, with 3 decimal places. I'll round up later, so 0.249, okay. This one's divided by 12, divide by 12, and 1 ounce, 12 ounce divided by 12 ounces, and you got 2.99 divided by 12, which equals, 0.2492, should have gone 4 decimals, alright. And divide by 12, divide by 20. Let's erase that, go back. Okay, divide by 20, divide by 20. So you got 5.99 divided by 20. This one gives us 0.299 for 1 ounce. Okay, let me go back, 2.4. Sorry, 3.99 divided by 16 equals 0.249375. I'm actually going to go all the way further. Okay, and then 2.99 divided by 12, 2.491. I think this is a non-terminating, so that's going to go on forever. Alright, in all reality, if this was your test and I made a mistake like this, I would have asked you to round this to the nearest hundredth. So this would have become 0.25. And this would have become 0.25. And either or, the 16 ounce or the 20 ounce would have had the same price. Okay, just to make life a little bit simpler. Okay. So for this one, 2 of them had the same price. Although if you went up to the 10,000th place, okay, right here, the bag that had a 12 ounce would be a little, I mean, very, very tiny difference, but it'd be a little bit cheaper. So, but on the test, had I made the mistake like this, round to the nearest hundredth, and they would have both had the same price. Okay. So, which one has the least value? -3 or this? Absolute value of -3. Okay, well, before you even start comparing, you have to first change this. Absolute value of -3 is 3. Remember, here's a number line. -1, -2, -3. What is absolute value asking you? Well, it's asking you, imagine if you were here on top of -3, how far are you from 0? You're 1, 2, 3 steps. We're measuring distance away from 0. So absolute value of -3 is 3. And now you can compare. So which one has the least value? Well, 1, 0, -1, -2. So you're comparing 2 numbers. Okay, one is -3, the other one's 3. Obviously, the one with the greater value is 3 because this A is on the right side. Okay, and numbers increase as you go this way. Okay, and you can clearly tell that 3 is greater than -3. Okay, Let's see, what else? Next one. Tony said, so you got two statements, negative 2.3, less than negative 2.35, less than negative 2.03. And Lisa says, no, that's not correct. This should be correct. Negative 2.35, negative 2.3, negative 2.03. Alright, so who is right? Don't take a guess here. I would use a number line, a wavy number line, and I would put these numbers in there. Here's 0. Okay, you don't need any positive numbers, so you're dealing with a bunch of negatives. So let me just make that a little bigger. Okay, so let's make that negative 1 over here. No. Alright, so we can, 0, negative 1, negative 2, negative 3. Okay, so let's plot all three numbers, and then we can tell. So this is Tony, and this is Lisa. Alright, so our first number, negative 2.3. Here's negative 2. I know negative 2.5 is in the middle, so negative 2.3 is somewhere over here. This is negative 2.3. Okay. Negative 2.35. Well, negative 2.35, it's a little bit to the left. So let me just write that number over there. And then finally we have negative 2.03. Negative 2.03 is a little bit less than negative 2. And there. You have it on the number line. Now you can tell who was correct, Tony or Lisa. Well, negative 2.35 is the smallest number. Negative 2.3 is the second smallest. And negative 2.03 is the biggest. So in order, it should be this one, smallest, second smallest, third smallest. And the only person that has that in that correct order is Lisa. Okay? So remember, with negative numbers, the bigger the number, the more to the left they are. Okay? It's backwards. Where am I? Trevor recorded temperature changes, blah, 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 blah. Okay, so here we go. So Monday AM, Monday PM, so temperature starts with 5, okay? And it dropped 11. So from 5, now why don't you guys draw something like this? That helps. Here's 0, here's about 5, and drop of 11. So if you're at 5 and you drop 11, you know that you have to pass through 0, and you're going a little bit further down. So from 5 to 0, that's 5, okay? 5 degrees that you have to go down. So imagine an elevator, you went down 5 floors, and you still got to go 6 more, because it's a drop of 11. So 5 and 6 does give you 11. So 5 to 0, it's a drop of 5, and you still have 6 more to go over, and that would put you at negative 6. So my first number, a drop of 11, gives me negative 6. So from negative 6 says I rise 15. Alright, so I'm going back up again. So I know that from negative 6 to 0, I travel 6. And then from 0, I'm going to travel 9 more, because 6 and 9 gives me a total of 15, which is how far my travel is supposed to be. So from negative 6, right here, I go to 0, which is 6, and then from 6, and then from 0, I travel 9 more, and these two gives me a total of 15, and I end up on positive 9. Okay? So, from 9, all of a sudden my temperature drops to 0. Okay, so from 9 to 0, that is a drop, of course, of 9. Okay, it goes down 9. Okay. And then from 0, it says I'm going to negative 8. And from 0 to 8 is a drop of 8. Okay, so if I'm a positive 9 and I go to 0, it means I went down 9. And if I'm at 0 and I go to negative 8, I dropped another 8. Okay. Next question. Okay. How am I going to do this? Okay. I'm going to. Okay. So graph a rectangle ABCD with an area of 20 square units, such that 2 of its vertices are in quadrant 2, and the other 2 are in quadrant 3. So you want a square. Oh no, rectangle. So you want a rectangle. Let me just get over here. Okay. Alright, so you want a rectangle, and this particular rectangle, okay, this particular rectangle is being Q2. So remember, this is Q1, this is Q2 right here, and quadrant 3 is right here. This is quadrant 4. And where do we want this? In 2 and 3. So our rectangle is going to be in here, in this location here. Okay, and it has to be a rectangle that has square units. So our rectangle, okay, our rectangle, so anything that gives us 20 square units, it could be a 4 by 5 or a 5 by 4. It could be a 2 by 10 or a 10 by 2. What else can it be? It can be a 1 times 20 or a 20 times 1. So any of these three, a rectangle, any of these 3 dimensions are okay. So let's just stick to the easiest one, a 4 by 5. So let me take any point. Doesn't matter where you plot them, as long as 2 of its vertices. So you got 1 point here. That's 1. That's 2. That's 3. That's 4. So let's make this 4 going this and 5 going down. 1, 2, 3, 4, 5. There. 4 vertices. 2 of my vertices are in quadrant 2, and 2 are in quadrant 3. Okay, and we have 20 units inside, so let's just close our rectangle. Okay. You want to label this? It's going to be A, it's going to be B, it's going to be C, and it's going to be D. Do we have 20? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so A is going to be 1, 2, 3, 4, 5, 6, 7, 8, no, 7. So point A for me is -7 and up 2. Point B for me is going to be 1, 2, 3, -3 and up 2. Point C is going to be -3 again, and go down 3, -3. And point D is going to be -7 and -3. Okay, so that's what I would have done. Okay, remember this rectangle can be moved, so you could have had a rectangle a little bit more to the left, as long, or a little bit higher, even a little bit lower. But as long as 2 of its vertices were in Q2 and 2 in Q3, you're fine. Next one, and it looks like we're getting to an end here. Let's draw a number line, hopefully a little bit straighter this time. Okay. And -4, so right. 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5, -6, -7. 3, 4, 5, -1, -2, 3, -4, -5, -6, -7. Okay, so it says start with the integer -4 and call it P. So right on top of -4, I'm going to write the letter P. Okay, and then it says A, label point A. So let's find point A, the opposite of P. Obviously, the opposite of -4 is 4, positive. And we're going to call that A. Easy. Now let's label point B, a number less than P. So to be less than P over here, you have to be here. Okay, any of these 3 numbers, -5, -6, -7. Okay, so let's pick -6. So -6 will be a number less than P. That works. And then says label point C, a number greater than P. Well, To be greater than p, you have to be on its right side. So any number, -3, -2, -1, 0, 1, 2, 3, 4, 5, any of these numbers would have been okay. So let's not make this too complicated, and let's just pick, I don't know, 1. 1 is greater than -4, so let's call that C. And that's it. Okay. Bottom one, determine if the numbers are counting, whole, integer, rational, or irrational. Okay, so let's do that. So 5. Okay, let's go. 5. I'm not going to write the whole word. Not going to write the whole word, but I will write. We'll write the abbreviation. There you go. 5. 5. It's a counting number. It's a whole number. It's an integer, and obviously it's also rational. Okay. -3.2. It's rational. -9. It's an integer, and it's rational. 5.5 or 5.5. Okay, it's just a rational number. 3.4444, and that, should have been written like this actually. The decimal that goes on forever, but it's a repeating decimal, so that makes it rational. Okay, a decimal that goes on forever and it repeats, it's rational. And the other one, 0.1343485746. Obviously, you get the point that it is a decimal that does not repeat and goes on forever, so that makes it irrational. Okay, a decimal that goes on forever and does not repeat is irrational. Okay, that's it. You can always email if you have any questions. Okay, I can go over a few other questions if you like me to. But if you're okay with this, you should be very fine come Tuesday. Okay. Yeah, I am forgetting something. So why don't we do? Okay. This is what's on TV right now. Try not to tell anybody. Okay. And that'll be the secret word. That's it. We're done.